Here we're looking at the settings menu for ColourSpace, which is within the main profiling window, and is where you can set the various values that are used throughout the profiling options. So initially we've got target, gamut, EOTF. At the moment they're all linked. They will be separate, so you will have gamut and EOTF gamma, but for now they're all interlinked. So Rec 709 is the fixed Rec 709 gamut with target gamma EOTF of 2.4. We can call it a gamma in this case because it's a pure power law, but EOTF is the real technical term for any target electro-optical transfer function. If you don't want to use the default, then you can make your own. So in the library, go into the default presets, Rec 709, modify, and you can change any of the parameters that you want, give it a new name and save it. Once you've done that, I won't do it just because I've got loads already, they will appear in the user color spaces. So here we've got 2.3 gamma, a couple of them, 2.6, just a couple of weird named ones, and they appear in our target list exactly the same. There you go, new name, test, new 2.35G, so on. We'll stick with our default 709. Subspace gives you the ability to target a smaller color space than the main target. So for example, if you're targeting UHD Rec 2020, you can select to work to say DCI P3. So you can actually see if your calibrated Rec 2020 display is capable of actually meeting DCI P3 color space requirements, being that most Rec 2020 material is presently graded to P3, and you can define whether you are working to a subspace code value or a target space code value. And again, the gamut and EOTF will be separated, but at the moment are interlocked. If you're not sure about the capabilities of something like subspace, you can actually use the existing Lightspace user guide, because the functionality is pretty much the same. So if we go into the Light Illusion website, go to Lightspace guides, and if we look at profiling and we look at display characterization, here we have color subspace, and if we go down there, it will give you the information on what subspace actually does and how it's used. It also then links you to how to use it for this alternate patch sets, which is where you can actually calibrate a display that is already pre-calibrated to a wider gamut that it can actually do. And yes, that is the JVC projectors pretty much, as is shown here. That actually says it's an extracted space, which uses exactly the process I just showed you for a new color space, but this time it takes a profile. So if we say something like the Convision one, we've used that before. Let's go to that one, the full raw, and you can see that it's a much larger color space than Rec 709, other than in blue. But if we actually select to modify that, we can use extract space to build a new matrix that uses the primary values from the display as well as extracting an average gamma EOTF. So you can use that within your subspace as your subspace target. Okay, below that we have, oh actually just while we're here, a bit of fun, we were looking at obviously just a default color space in the sense of LG Rec 709, HLG Rec 709 PQ, but also here we have cameras because we have the camera option on this license. So you can see a standard Rec 709 camera, ARRI, here we go, the ARRI gamut, what else have we got, red, there you go, just show you some of the interesting differences of the various cameras. Anyway, back to Rec 709. Luminance target, like most of the settings in ColourSpace, they are remembered. So if you modify them, when you start up next time, the modified values will become your kind of defaults within limits. But here we have standard for standard dynamic range of 100 nits max, 0 nits minimum, both for the target and the profile data, because this is a new profile. It has no measured data, so it's just got the default stuck in as a starting point. So if we want to actually chase a target and know what this display is preset to, so we can use that when we're defining things such as gamma, we need to connect a probe. So we'll connect to an I1. We'll stick up a color patch. There we go. And we can use auto to automatically update the min and max values. There you go. And that gives you obviously the contrast ratio now. In the profile loomer, these values will update every time we take a min and max value, either manually or via a automated profile sequence. So if we measure black and measure white, those values are now updated here. You can see they're basically the same. The display is pretty stable. The up arrow will take these values and replace the values here with them. So if we were to manually put our target back to the defaults of 100 and 0, you can see they've gone yellow. And what that's telling you is that these targets are not what the display is actually capable of doing, not what the display's actual response is. So that kind of power yellow just lets you know that there is a differential going on here. If we hit the up arrow, it just transfers this data into these boxes. If we click the auto, every time we remeasure a minimum or maximum, so a black or white, in the measure or in a fixed profile, then it will actually automatically push those values back up. So again, if we default these back to 100 and 0, go in here and we measure white and measure black, when we go back, it's been repopulated because the values we've just measured have been pushed up, and will be done every time, so that when you're setting things like gamma and so on, the values will continually update every time you make a manual adjustment of the black or white point. Okay, stabilization gives you the ability to add a patch in between every read patch. So it inserts a patch that is not red for the duration that you set and of the color that you choose to set. Black is the most logical because you're looking to cool the display down in between taking brighter patch readings. You've then got the patch size and background color controls. These are either set via your own custom values using area as well as positioning for X and Y in percentages, or from our preset. So L2 is 10%, which is fairly much the standard for things like HDR. You can obviously set the background color as well. Again, black is obviously the most common, but if you want to do kind of a mid-grey or something, then you can obviously set that, and that will become your background color. Now, when we open our patch window, at the minute, it's actually all the same color, because when the floating patch window is not full screen, the size value is ignored. If I double click it, you can see that it goes to the patch size that we've set with the background color that we've set. If you're using an external patch generator that can do APL or similar, then obviously that will also become controllable via the hardware controls for your patch generator. But these are for the internal patch generator, but also for setting things like size and that for external patch generators. Then we've got patch scale and resolution. Patch scale is the range that you're working to. So data range 0255, video range, or video range with super white and so on. or you can actually set obviously custom and set your own values that you want manually. The resolution at the minute, this is just for the GUI controls. Inside ColourSpace it's actually floating point, so it's irrelevant, but at the moment we're actually working 8 bits for our GUI, but it will have the option of 8-bit, 10-bit, 12-bit, what have you. But at the moment we just use 8-bit because it actually makes no difference, because you're setting a value so long as the value sent to the display is the same as the value set here. Everything works irrespective of the actual bit depth of the patch generator and display in use. We've then got pre-roll CSV sequence, a comma separated variable, so an Excel sheet basically, which allows you to run a patch sequence in advance of starting to take readings, so that you can warm up a display, and you just navigate to the sequence that you want to use. So memory list random, and there you go, it's in the list, and it will now run that before we do a profile with the time set per patch. Just deletes it. This will be a library at the minute, it's just one at a time. And then lastly we have active LUT. So if you have a LUT in the system, so let's just load in a LUT. Film emulation, there we go, and there you go. So if I just double click that, it's a standard film emulation LUT, and we're just going to use that as an example. So now when we go into active LUT, it's there, and you can see the change in the patch color immediately, because the patch color is now being pushed through the LUT before it is sent to the display. You can use that for advanced calibration of non-standard displays, or for the verification of a LUT that you've made before you upload it into the display of a LUT box. I think that pretty much covers the settings menu.